I'm Dean Zody. I'm founder and CEO of Ghostwave. And we have radar products. And I'm going to start out with why radar products and why do we use them with ADAS. And now, does everybody know what ADAS is?
Nope.
It is adaptive. What is it? Advanced Driver's Assistance Systems, or adaptive, one of the two. Anyway, it's for your blind spot detection, lane change assist, self-driving cars, everything that does to help you, all the equipment stuff to help you with your cars. And some people think like radar is like old technology. Really, when you look at what's going on with the LiDARs, the cameras and stuff, radar is still going to be there. It's going to be a key automotive sensor going forward. You think of Tesla and what they have going on, radars are the backup. They're the redundancy systems. Radars give you distance and speed information. It's not impacted by fog, rain, snow, and it hides behind bumpers well, and just generally a good solid technology for ADAS systems. So we're going to go through two technologies today with that radar that Ghostwave has for radars. One is RF noise radars, and the other one is what's called a vehicle obstacle detection radar. So the first one, RF noise. Believe it or not, there's a problem. And in a report from Bosch to the FCC, they said if two overlapping bands are within the same vicinity, mutual interference will occur. Radars are going to talk to each other, and they're either going to see a ghost image or they're going to say, I don't know what's going on. And so when you do your lane change assist, it's not going to help you out because there's interference. And most recently, in Microwave Journal, which I'm sure you all subscribe to, no? I do, it's awesome. But anyway, this year there's going to be 72 million new cars registered. So doing simple math in public, which I don't like to do, if there's 3 radars per car, that's going to say there's over 200 million new radars on the road just this year. So from Microwave Journal, it says, the sensors could be on the streets, not too distant future. These frequencies will need to cope with the mutual interference. So I'm not up here saying there's mutual interference because I have these neat radars. It's other people, Bosch who makes radars, Microwave Journal says this is a problem. As we get more and more cars on the road, newer cars on the road, it's going to become a bigger and bigger problem. So what do we do about it? Well, Ghostwave has radars using RF noise technology. It's technology that's immune from interference of neighboring radars. It works and plays well with other RF equipment in the area. And like typical radars, distance and velocity, inclement weather, ultra-wideband spreads technology. And although it's currently developed in, I'm trying to think, it's kind of like an older technology, RF noise. It's easily adaptable to current chip radars. Radars, because of the proliferation of what's going on in the auto industry, have basically become roaches, what they call radar on a chip. So they're becoming smaller, they're becoming cheaper, and this technology fits into what's going on with the chip makers and the radars. So what is RF noise? RF noise is what's around you right now. You have cell phone towers. If you remember old TVs that had static on the tube, or AM radio where you hear static, that's just RF noise. So, these radars look at what's the RF noise around it, generates a signal that is similar to the RF noise around it, and that's how it stays immune from interference because it knows what it's sent out, but it also is kind of blending in so it's not interfering with other things in the area. You're probably still like, huh? Right? So, what's your favorite song?
I'll do Heart of Gold by Neil Diamond.
Okay, so we have Heart of Gold by Neil Diamond on one speaker here. We have Purple Rain coming out over there. We have Stairway to Heaven coming out over there. We have Keith Urban coming out over here. Can you still hear Heart of Gold even though there's 5 or 6 different songs playing?
Probably not.
No, actually I think you can. The answer is yes. Okay. You have all these songs playing, but if you're listening for one song, you can hear that one song. And that's Ghost Wave. We work in a radar cluttered environment. There's all kinds of RF noise, but we know that one thing we sent out, and we're looking to hear that coming back. So that's kind of the technology in a nutshell. So again, I kind of mentioned this before. This isn't new. Several years ago, the U.S. Army went to Ohio State University and said, we want stealthy radars. And the reason they want stealthy radars is if they're flying the helicopter around, they don't want somebody to lock in on the signal of the radar and be able to shoot it down. So Ohio State came up with radars that were stealthy, but they're on the bottom of the helicopter, and it says, excuse me, pilot, somebody is shooting at you, and it's this caliber of a bullet, and this is the evasive action you need to take. So maybe it's just like, well, the bullet's never going to hit you, don't worry about it, or go up high, or get out of there fast. It's been proven at 10 megahertz, which is not in the automotive industry, but still is a technology that's been proven. And now we're taking that technology and moving it to the 24 gigahertz range, which is what's used in the automotive world. And they're patented by Ohio State. We have a model that's at the Ohio State Electroscience Lab. Actually, we're having some mixer problems right now we're working through. But essentially, we've taken the technology, built a 24 gigahertz model, and back to what we mentioned earlier on with Microwave Journal, which you were all subscribing to, they put in testing on this is how you're going to test for interference. And we're putting through the radar with that interference testing so we can document and show our future customers this is what's going on. The next product, vehicle obstacle warning radar. Again, this one transmits a narrowband signal, and it's received back on multiple antennas. So you're transmitting out behind a bumper, but you have, in this example, we have 8 different antennas coming back. And what's going on is we're taking a processor, writing an algorithm, so those signals coming back help define the signal a little bit clearer. It says, hey, this is something big, you need to stop now, or hey, this is approaching fast, you need to do something about it. Or it could be this is just a pothole or a curb, don't worry about it. So it's kind of like a lot better than the technology you see on the back of cars right now. We kind of discriminates between high and low priority objects. So what's really cool about this is, one, I have it in my backpack. So this technology is really kind of cheap. It's flexible, so it can fit on the back of your car. So currently you see the bolt holes of the ultrasonic sensors for your rear end collision warning. Those just tell you if something's there or not. This will tell you how fast it's coming at you, how big it is, and being just a printed circuit is pretty darn cheap too. So we're taking this radar technology, and we have people interested in this as far as replacing the ultrasonic sensors on the back of the cars, which is kind of shown here. Again, this was developed by Ohio State and patented by Ohio State. Originally, a company was working on a school bus company came to them to ask them to work on this project. They did, they weren't interested, they still had the patents. Since then, the industry has changed a lot with the rear end collision avoidance, and this is what we came up with. The Ghost Wave team, myself, we have, I'm the only one on the team who's not a doctor. No. I guess that's good, I'm not sure. Dr. Walton, who retired from Ohio State, came up with the RF noise radar. Dr. Walton and Chi-Chi Chen came up with this patent for the school bus rear end collision avoidance, or actually just noticing what's behind the buses. And then Dr. Vladimir Villarol, he has his PhD in electrical engineering. He has an MBA, he has a law degree, And he's basically our antenna guy. So he's provided a lot of help for us too. What we talked about, we had the RF noise patent. We have the vehicle obstacle warning radars. Both those are patented by Ohio State, and they have licensed those patents to Ghostwave. Background, we're here in Columbus, Ohio. We have technology that can discriminate between high and low priority objects. We have the immunity from RF interference. And generally, we're just a radar company finding new solutions for people. And I'm sorry to offend Surrey, but where were we? Oh yeah, I mean we have some projects going on. We're a radar company who's working on solutions, and when we're getting together working on stuff, some cool project or some cool products come out of it. So again, we're just kind of like a radar systems company. Right now, we're bootstrapped to date. We applied for the Ohio TVSF grant back in June, and per their scoring system, they went through 14 different companies. They awarded it to 4 companies. We were 5th. Gave us a lot of feedback, so we're optimistic for getting that the next round. We have other new investors waiting to invest following the TVSF funding. What we're looking for investors, we're looking for development partners, and we're also looking for new customers. That's me. We'll end it with a quote. Jonathan Pettit, PhD out of Europe, working for security innovation here in the United States, had a great quote during the presentation, at least I thought, and that is, if a self-driving car has poor inputs, it will make poor driving decisions. We're hoping with our radars that we'll have good inputs for the good driving decisions. All right, that's it. Thank you. Any questions? Yes.
When it comes to partners and customers, what's kind of the ideal profile for what kind of customers are you seeking out? What kind of partnership opportunities?
Sure, I guess we're twofold on that. We're working with an engineering firm now, working on radar systems. But additionally, when you look at the automotive industry, it's the tier 1 suppliers that are pushing the new technology to the automotive OEMs. So, from a development perspective, we'd like to be working with a tier 1 supplier. Yep.
How does your radar system work and play well with the State Highway Patrol speed trap radar systems?
One, they're using a different frequency than what we're using. But again, because we're transmitting based around the RF noise in the area, it doesn't interact with that. However, I have read stuff about this, especially on Audis, that they have the blind spot detection and lane change assist radars. They are setting off people's radar detectors. Yeah.
So if I understand correctly, you're like listening to a certain band or frequency for what other frequencies are being used, and then you select one that's not being used, or?
No, we look at the static, and we send out, although it's going to be a 24 gigahertz noise that we send out a signal that is reflective of the static around it. It's called a pseudo-random noise generator. But then we store that in a FIFO. So when it comes back, we compare the signal that we sent out to the one that's in the FIFO when it returns. And that's how we get the Doppler and the movement and the size of the object. Okay.
So even if you have like 2 of the same ghost wave cars coming towards each other,
they're going to be sent out different random noises.
Okay.
Yep,
Cool.
exactly. Good question. Thanks. Yeah. Anybody else? All right. Thank you.